The urge to classify plants has been with man since he first set his foot on this planet, born of a need to know what he should eat, avoid, use and cure for ailments, and utilize for his shelter. Initially, this information was accumulated and stored in the human brain and passed on to generations through word of mouth in dialects restricted to small communities. Slowly, man learned to put his knowledge in black and white for others to share and improve upon. We have now searched a stage whereby a vast amount of information can be conveniently stored and utilized for reaching conclusions aimed at developing ideal system of classification which depict the putative relationships between angiosperms, between organisms. Historical development of classification has been through four distinct approaches, beginning with simple classification based on gross morphology to the latest phylogenetic systems incorporating all the modern phonetic information. The main aim of modern taxonomy is the identification and classification of organisms. The distinction between these two goals is important and often overlooked. Plant identification is the determination of the identity of an unknown plant by comparison with previously collected specimens or with the aid of books or identification manuals. The process of identification connects the specimen with a published name. Once a plant specimen has been identified, its name and properties are known, whereas the plant classification is the placing of known plants into groups or categories to show some relationship. Scientific classification follows a system of rules that standardizes the results and the group's successive categories into a hierarchy. The classification of plants result in an organized system for naming and cataloging the future specimens and ideally reflects scientific ideas about plant interrelationships. Now we'll see about taxonomy and its origin. Taxonomy is the method by which scientists, conservationists and naturalists classify and organize the vast diversity of living things on this planet in an effort to understand the evolutionary relationships between them. Modern taxonomy originates in the mid-17th century when Swedish-born taxonomist Carl Linnaeus published his multi-volume Systema Naturae, outlining his new and revolutionary method for classifying and especially naming living organisms. Prior to Linnaeus, all described specimens were giving long, complex names that provided much information than was needed and were clumsy to use. Linnaeus took a different approach. He reduced every single described species to a two-part Latinized name known as binomial name. Thus, through the linear system, a species such as the log rose changed from long, difficult names such as Rosa sylvestris, Indora sucanina to the shorter, easier to use Rosa canina. This facilitated the naming of large number of newly explored species. Linnaeus spent a great deal of time in describing and naming new plant specimens that were sent to him from around the world by other botanists, including from the newly explored regions of the New World. Although somewhat rudimentary by today's standards, Linnaeus' method of describing species in such a way as to represent the relations between them changed the face of taxonomy and allowed biologists to better understand the complex natural world around us. Linnaeus' classification system and his other contributions are also discussed later in the topic. Now we'll see about the history of plant taxonomy from the early historic to modern period, which is discussed as early literate civilization. Early civilization flourished in Babylonia, Egypt, China and India. Through the written records of Indian botany appeared several centuries before those of the Greeks. They remained in obscurity, not reaching outside the world. Moreover, they were written in Sanskrit, a language not easily understood in the West. Crops such as wheat, barley, dates, melons, and cotton were grown during the Vedic period 2000 BC to 800 BC. Indians obviously knew about descriptive botany and cultural practices. The first World Symposium on medicinal plants was held in the Himalayan region in the 7th century BC. The Atharva Veda, written about 2000 BC, described the medicinal uses of various plants. Now we'll see about the history of Theophrastus and his contributions. He is also known as the father of botany, and he is the successor of Aristotle. He is credited with having authorized more than 200 works, most of which survive as fragments in the form of quotations. In the works of other authors, 2 of his botanical works have survived intact. However, these are available in English translations. Number 1 is Enquiry into Plants, has been authored or published in 1916, and The Causes of Plants, which has been published in 1927. Theophrastus described about 500 kinds of plants, classified into 4 major groups: the trees, shrubs, subshrubs, and herbs. He also recognized difference between flowering and non-flowering plants, superior and inferior ovary, free and fused petals, and also fruit types. He was aware of the fact that many cultivated plants do not breed true. Now about medieval botany. During the Middle Ages, 5th to 15th century AD, little or no progress was made in botanical investigations. During this dark period in history, Europe and Asia witnessed wars, famines, and epidemics. And the only worthwhile contribution were copying and recopying of earlier manuscripts, unfortunately often with errors added. The strawberry plant was thus shown to have 5 leaflets instead of 3 in several manuscripts. The manuscripts were lost at a faster rate than they could be copied. Now about Islamic history. Islamic history of botany. The ascent of the Muslim Empire between 610 to 1100 AD saw the revival of literacy. Greek manuscripts were translated and preserved. Being practical people, they concentrated on agriculture and medicine and produced the list of drug plants. Ibn Sina, better known as Avicenna, authored Canon of Medicine. Another Muslim scholar, Ibu-al-Awwan, in the 12th century described nearly 600 plants and interpreted their sexuality as well as the role of insects in fig pollination. Although Muslim scholars produced several practical lists of drug plants, but did not develop any significant scheme of classification. Now we'll see about Renaissance in the field of botany. 15th century saw the onset of the Renaissance in Europe with technical innovations, mainly the printing machine and the science of navigation. Invention of printing machine around 1440 ensured wide circulation of manuscripts. Navigation leads to the successful exploitation of botanical wealth of distant places. About herbalists. Herbalists were the authors of the medically oriented books on plants. Such books came to be known as herbals. These were easily understood as compared to ancient manuscripts. Otto Brenfels, 1464 to 1534, wrote Herbarium Vivi Icons in 3 volumes. In 1530 up to 1536, this herbal marked the beginning of modern taxonomy and contained excellent illustrations prepared from living plants. The text, however, was of little value, comprising extracts from earlier writers. The first herbal were published under the name God dar Jacendier or Hortus Sanitatus. These were cheaply done and are of poor quality. The outstanding herbals come from German Herbalists Otto Brunfels, Jerome Bock, Valeris Cordus, and Leonard Fuchs. These all are constituting the German fathers of botany. Now we will see about the earlier taxonomists. With renewed interest in plants and extensive exploration of Europe, Asia, Africa, and the New World, the list of plant names increased enormously, signifying the need for a formalized scheme of classification, naming and describing plants. Botany hitherto depends on medicine, started to spread its wings as a science per se. André Casson-Pino, or we also say Andrea Cisalpino, in 1519 up to 1603, the first taxonomist. Andrea Cisalpino was an Italian botanist who studied botany under Luca Ghini and became the director of the botanical garden and later professor of botany and medicine at Bologna. He went to Rome in 1592 as the personal physician to Pope Clement VIII. He prepared a herbarium of 768 species, well mounted, in 1563, which is still preserved in the Museum of Natural History of Florence. His work De Plantis Libri in 16 volumes appeared in 1583 and contains the description of 1520 species of plants grouped as herbs and trees and further differentiated fruit and seed characters. He highlighted the significance of reproductive characters and altitude, not liked by his contemporaries but having much bearing on the subsequent classification of Ray, Turnford, and Linnaeus. Now we will see about the Gaspard Buhin and his contribution. He appeared in 1560 up to 1624. He was a Swiss botanist. Buhin travelled extensively and formed a herbarium of 4,000 specimens, rather to say. He published Phytopinax in 1596 and Pinax Theatri Botamsi in 1623, containing a list of 6,000 species of plants and gave synonyms, that means other names used for a species by earlier workers or earlier authors. And he introduced the binomial nomenclature of several species with certain confusions. Although he did not describe the genera, however, he recognized the difference between species and genera, and several species were included under the same generic name. Now the contribution of J.P. Turnford, who is also known as the father of genus concept. He is a French botanist. D. Turnford studied under the Perry Magnol in the University of Montpellier and later became the professor of botany at Jardin du Roi in Paris and later director of Jardin de Plantis in Paris. He published Elements de Botanique 1696, including 698 genera and 10,146 species. He was perhaps the first to give names and descriptions of genera, merely listing the species. Caspar Buhin, who did recognize genera and species, provided no such description. Turnford was thus first to establish genera. A turning point in the classification approach was establishing the fact of sexuality in flowering plants by Camerarius in 1694. He concluded that stamens were male sex organs was necessary for seed set. He showed that the style and the ovary form female sex organs of a flower. The thought regarding the sexuality in plants was ridiculed by the church authors. Now we'll see about the Carolus Linnaeus and his contribution. Carolus Linnaeus is also known as father of taxonomy. He appeared in 707 up to 1778, was also known as Carl Linnaeus or Carl von Linnaeus, whereas Darwin dominated botanical thinking during the 19th century. Linnaeus did so during the 18th. Linnaeus, born in Raschelt, Sweden on 23rd May 1707, he published his first paper on sexuality of plants in 1730. Following favorable publicity of his paper, he was appointed as demonstrator and subsequently promoted as docent. In the same 1730, he published Hortus Upplandicus, enumerating the plants in the Uppsala Botanical Garden according to Turnford's system. Faced with problems of increasing number of plants, which he found hard to fit in Turnford's system, then he published a revised edition of Hortus Upplandicus with plants classified according to his sexual system. In 1753, he published his best known species Plantarum. His growing fame and publications attracted a large number of students, their number increasing every year, and the botanical garden at Uppsala enriched considerably. In his genera Plantarum, he listed and described all the plant genera and species known to him. The system of Linnaeus, very simple in its application, recognizes 24 classes, mostly on the basis of stamens. These classes are further subdivided on the basis of carpal characteristics into orders such as monogyna, digyna, etc. Such a classification based on stamens and carpals resulted in the artificial grouping of unrelated taxa and separation of relatives. Linnaeus knew that his system was more convenient than natural, but it was the need of the day when there was a tremendous increase in the number of plants known to man, which necessitated quick identification and placement. This is exactly what the sexual system of Linnaeus achieved with merit. His species Plantarum, published in 1753, marks the starting point of botanical nomenclature today. Now we'll see about the natural system of classification. Although Linnaeus had provided a readily referable cataloging scheme for a large number of plants, but it soon becomes evident that unrelated plants come together in such groupings. A need was realized for a more objective classification. France, which was undergoing an intellectual ferment and where the Linnaean system never became popular, took the lead in developing natural system of classification. Then Michael Adanson, a French botanist, unimpressed with artificial choice of characters, devised the classification of both animals and plants on the equal use of many features as possible. In his 2-volume work, Families des Plantes, published in 1763, he recognized 58 natural orders according to their natural affinities. Present-day numerical taxonomy is based on the idea conceived by Adanson and now developed into neo-Adansonian principles by de Candolle family. The de Candolles were a Swiss family of botanists. Augustin Pyramus de Candolle appeared in 1778 to 1841, was born in Geneva, Switzerland, but took his education in Paris, where he became the professor of botany at Montpellier. He published several books, the most important one being Theorie Elementaire de la Botanique. The classification of A.P. de Candolle delimited 161 natural orders. The numbers were increased to 213 in the last version of Theorie élémentaire de la botanique, edited by Alphonsine in 1844, grouped primarily on the basis of presence or absence of vascular structures. Ferns were provided a place coordinate with monocots, and in contrary to D'Souza, gymnosperms were given a place although among dicots. After Candolle, the two English botanists, George Bentham and Sir J.D. Hooker, jointly produced the first elaborated natural system of classification in their 3-volume work Genera Plantarum, published between 1862 to 1883, a classification of seed plants recognizing dicotyledons, gymnosperms and monocotyledons as distinct groups in all 202 natural orders, now treated as families, were recognized, grouped into cohorts. Cohorts are now known as orders and series. The description were based on the original studies of specimens and dissection of plants themselves, and did not represent a mere compilation of the existing literature. Genera Plantarum, though published after the Origin of Species by Darwin, is pre-Darwinian in concept. The species were regarded as fixed entities, not changed through time. The descriptions were accurate, authentic, and no doubt the system is still useful and followed in several major herbaria of the world. The publication of the Origin of Species by Charles Darwin, with every copy of first edition sold on the very first day, 24th November 1859. This revolutionized the biological thinking. The species was no longer regarded as fixed entity, having remained unchanged since its creation. Species were now looked upon as a system of populations, which are dynamic and change with time to give rise to lineages of closely related organisms. Once the existence of this evolutionary process was acknowledged, the system of Candolle, as also of Bentham and Hooker, were found inadequate, and then attempts were made to use evolutionary sequences in classifications. Now about Adolf Engler and Karl Brandt. Engler and Brandt, the two German botanists, developed a system of classification published in their monumental work Die Naturlichen Pflanzenfamilien, appeared in 1887 to 1915 in 23 volumes, covered the entire plant kingdom. The work included the keys and descriptions of all the known genera of plants. The seed plants, Embryophyta Sphenogyma, were divided into gymnosperms and angiosperms, and the later into monocotyledons and dicotyledons. The two subclasses of dicots were named as Archiclamidae, petals absent or free, and Metaclamidae, petals fused. In the light of current phylogenetic views, the system of Bentham and Hooker, as are also of Engler and Prandtl, are now obsolete, though they continue to be the most dominant systems followed in the flora and herbaria. Now we will see about intentional phylogenetic system. The natural system, rearranged in the light of phylogenetic information, soon gave way to systems that reflect evolutionary development. A beginning in this direction was made by an American botanist, Charles Bassey, who laid the foundations of intentional phylogenetic classifications. He was a student of Isagre and later became professor of botany at the University of Nebraska. He was the first American to make a major contribution to plant classifications, and also the first botanist to develop intentional phylogenetic classification. Bassey considered angiosperms to have evolved monophyletically from Cycadophyta, belonging to implied Benitutalian ancestry. He was the pioneer to consider that the large-sized bisexual flowers of Magnoliaceae with spirally arranged floral parts represent the most primitive condition in angiosperms, a theory followed by many subsequent authors. Now, about the contribution of John Hutchinson. Hutchinson appeared in 1884 up to 1972, a British botanist associated with the Royal Botanical Garden at Kew, and developed a system of classification which appeared in the final form in third edition of his publication, The Families of Flowering Plants. The classification was based on 24 principles, recognized 411 families of flowering plants. Dicots are considered more primitive than monocots and divided into two groups, Lignosae and Herbaceae. Magnoliales are considered most primitive dicots. The division of dicots into woody and herbaceous lines has, however, received wide criticism. Several closely related families have been separated and placed in distinct groups. Takhtajan, a Russian botanist, developed a classification system of flowering plants which was periodically revised, the last version being published in 1997. Takhtajan placed angiosperms in division Magnoliophyta, divided into two classes, Magnoliopsida dicots and Liliopsida monocots. These classes were divided in turn into subclasses. Phylogeny, unfortunately missing in the 1997 version, are provided, indicating the putative relationships of groups later being represented by balloons or bubbles. Hence the name bubble diagram of different size, indicating the relative number of species in the groups. Because of the elaborate bubble diagram and its unique display, Woodland has aptly named it Takhtajan's flowering garden. Now about Arthur Conquest's contribution. Working with the New York Botanical Garden, Arthur Conquest appeared in 1919 up to 1992, first proposed his classification in 1957 and went on to publish major revisions in 1968, 1981 and in 1988. He recognized 6 subclasses in dicots and 5 in monocots. His classification closely resembles Takhtajan's in placing angiosperms in division Magnoliophyta, divided similarly into Magnoliopsida dicots and Liliopsida monocots. Whereas Takhtajan attached more importance to cladistics, Conquest gives more weightage to the phenetic relationships in the placement of various groups. The phylogram in the form of bubble diagram has also been proposed, but it is not as elaborate as that of Takhtajan. Now the contribution of Robert Thorne. Thorne, born in 1920, an American taxonomist, has developed and periodically revised a system of classification that approaches the above two systems but differs in that angiosperms are ranked as a class and not a division. Thorne first put forward his classification in 1968 and proposed revisions in 1974, 76, 81, 83 and in 1992, 99, 2001 and 2003. Thorne had earlier divided angiosperms into dicots and monocots into subclasses, divided further into superorders, orders and families. However, in 1999, he has discarded monocots and dicots and instead directly divided class Angiospermi Magnoliopsida into 10 classes, with monocot taxa placed in between primitive dicots and more advanced ones, eudicots of AGP. In the last version of 2003, available on the website, he recognized 33 superorders, 90 orders and 489 families. Now about the contribution of Rolf Dahlgren. Dahlgren appeared in 1932 to 1987. Danish botanist first proposed his classification in 1974 with revisions in 75, 1980, 1981 and 83. His classification closely similar to earlier versions of Thorne in using the name Magnoliopsida for angiosperms, Magnolidae for dicots and Lilidae for monocots. His wife Guttard Delbene published an updated version of his classification in 1989. Now, dear students, we will see about the Angiosperm phylogenetic group. The ball was set rolling by Bremer and Weintraub, who appeared in 1978 up to 1981, who suggested that angiosperms should not be divided into monocotyledons and dicotyledons. They should instead be divided into number of monophyletic groups directly. Dedicated efforts of nearly 2 decades by a group of workers of the Angiosperm phylogenetic group resulted in the development of AGP classification in 1998. A recent cladistic analysis are revealing the phylogeny of the flowering plants in increasing detail, and there is support for the monophyly of major groups above the family level.